Alright folks, time to wrap up our Module 5 notes. This is going to be your last set of notes for this particular module because we're getting ready for the post-module review. Taking a look at this 5-21 post-module review, we'll put our Roman numeral over here. We need a 10, a 20, and then 21. Go ahead and put our lines across the top and bottom there. Alright, post-module review. Now, I'm going to condense some things down because, honestly, a lot of this lessons in this particular part of the module are building on each other. So I don't think we need necessarily entries for every single one. You should have your original notes, and you have access to the original videos if you want to go back and double-check anything. For Part A, we're going to put 510 and 511 together because both of these sections dealt with area of rectangles with mixed numbers. This is actually going to continue even further in, but for right now, 510 and 511 both dealt with area of rectangles with mixed numbers. More accurately, with 511, that was mixed numbers. 510 was just with fractions. It works much the same. What you need to be able to do is take a look at a rectangle. We spend a lot of time looking at rectangles. And recognize, okay, if this is 4 centimeters, it's not even close, but we'll pretend, and this one is 7.5 centimeters, also not even close, we use our formula, area equals length times width. Length in this case would be 7.5 times our width of 4. Now, commutative property of multiplication tells us order doesn't really matter. Width times length works just as well. But 7.5 times 4. Now, I cannot multiply them as they are. I have to change the mixed numbers into improper fractions. I have to change the whole numbers into improper fractions. So, 7.5 is going to be the same as 2 times 7, 14, plus 1 is 15. 15 over 2. 4 will just become 4 over 1. It's 4 ones, 4 wholes. I could multiply straight across. I would get 60 over 2, and that's no problem, but you know how much I love to cross-cancel. And I can divide both of these by 2. 4 divided by 2 would be 2. 2 divided by 2 would be 1. 15 times 2 is 30. 1 times 1 is 1, which means our answer is 30 centimeters. Dealing with area means they're centimeters squared. Square units, square centimeters. Again, if I had multiplied 15 times 4, I would have gotten 60. 2 times 1 is 2. 60 divided by 2 is 30. I would have gotten the same thing. Most of Module 5, Lesson 10 and 11 deal with these kinds of problems. We also talked about some ways that you can use tiling. You can draw a diagram and kind of use that model to help you. I think for most of us this is probably going to be the most comfortable way, but on the test you have both options available to you. Now, for this next section, we are once again going to put a bunch together. We talked about Lesson 512 through 5-15. Now, what all of these had in common is basically applying what you did above. Okay? Problem solving with area and fractions, but we'll just leave it as that. Okay? We're not going to do a full example here. There are plenty of problems you can look at in these areas if you feel like you would like more practice. Okay? But the big thing, if you can solve word problems, and actually let's start with this. Sorry, folks. Okay? If you have mixed numbers or whole numbers, make them improper fractions. We kind of talked about that up above, but I'm going to change my original notes a little bit and make sure we include it here. If you have mixed numbers or whole numbers, make them improper fractions. Make them improper fractions. Now, the other thing that I was going to mention, draw a diagram and label it to help you visualize the problem. Now, sometimes that means you are using a tape diagram. Sometimes that means you're drawing a rectangle like we did up here. Draw a diagram. Take the time to do that. Okay. Label it. Make sure you understand what the problem is asking and that you can really see it. Now, those two, it's about half the page, covers a pretty decent chunk of this section. Part C is going to be everything else. Lessons 5-16 through, Virginia doesn't like that, 5-16 through 5-20. For this section, or rather these sections, this is when we were talking about quadrilaterals. I always feel bad when I'm recording this at home and Virginia's upset. I promise, Mrs. Landre's out there checking on her, so she's okay. She's good. I don't even know how much that shows up in the videos, but she's not happy. 5-16 through 5-20, quadrilaterals. I am going to go through a diagram with you. I may pause and restart the video in certain points. You may want to pause and restart, or at least pause and continue the video, because we're basically going to fill out the rest of this page with a hierarchy of quadrilaterals. We're going to do one of those diagrams. Let's see if this helps at all. We're going to start, and it kind of goes across a few lines, because I want you to see how none of these are really parallel. None of these are really equal. Okay. This slants more than that. Okay. None of these are quite right. The only thing that this shape has is 4 sides. There are no parallels, really not any special angles, maybe one right angle, but nothing fantastic. This is a quadrilateral. It's got 4 sides. That's what defines it. Fantastic. Now, this is one example of quadrilaterals. We know from all of our work in class, obviously, they come in many flavors, many varieties, many types. Okay? We're going to go from this quadrilateral to one of the first types. So you're going to want to skip a line with your little arrow. And then down here, we are going to draw a kite. Now I'm going to start with what looks like part of a triangle. I'm going to put kind of a smaller triangle down on the bottom. The important thing with a kite, and I'm sorry I'm talking triangles, that's just how I visualize it. Obviously it's a quadrilateral, it has 4 sides. But for the kite, those sides are congruent to each other. They're consecutive and congruent. These sides down below are congruent to each other as well, but not those. So with a kite, you have two pairs of congruent sides. Two pairs of congruent sides. Now, we won't really be talking too much about congruent sides for a while. We see a couple other examples. But a kite, when you're looking at the angles, again, nothing really special, not necessarily any parallels. You're mostly, this is what you're looking for a kite. Does it have two pairs of congruent sides? Here's a pair, here's a pair. Okay. Now, we'll leave the kite alone for a little while. We'll come back to it. But for now, you're going to draw an arrow from the quadrilateral that goes way over here, or as way over there as I can make it, because this next one is going to get broken up a few different ways. This next shape we're going to make with one pair of parallel lines. One pair. One. And I keep underlining the numbers because, as I'm sure you can tell, that's pretty important. One pair of parallel lines. One pair of parallel lines. We got this, we got that. But the other two are not parallel. If I continue them, they're going to intersect. And this is a trapezoid. Now, it's worth reviewing at this point. The trapezoid is also a quadrilateral because I could follow this arrow back upwards. So it's a trapezoid and a quadrilateral. It's both. The kite is also a quadrilateral, but it's not a trapezoid. There is no arrow connecting these two. So there is no real overlap between these two. Okay. Now, with our trapezoid, we can go two directions here. The first, go down to about there. Okay. The first is going to start very similar. Actually, let's put it here. Okay. It's going to start very similar. But the key on this one is that both of these sides need to be congruent. Now, this one actually looks a little more like that than I meant, so I'm going to adjust it just a little bit. Because this side and this side should not be the same. If they are the same, then we have a different figure. We have an isosceles trapezoid. And we know it's an isosceles trapezoid because it has congruent legs. Now, it also has one pair of parallel sides, just like a regular trapezoid. And I'm sorry, I've got to fix my arrow because it's bugging me. I want it pointing at the figure. There we go. Okay. It also has one pair of parallels. It is a trapezoid. But it's got congruent legs. This one does not. So an isosceles trapezoid is a trapezoid, and it is a quadrilateral. Okay. Now, we said the trapezoid could go one of a few ways. The other way it's going to go, and this time I'm going to be smart, I'm going to start with this. I'm going to start with my arrowhead, and then we'll go and meet it. There we go. Not too bad. Okay, sorry, I don't think that was actually on the screen for most of it. One pair of parallel lines. Okay, fine. But what happens if we have two pairs of parallel lines? Not just this, but also these. So we started with one pair of parallel lines, but then this trapezoid gets a second pair of parallel lines, and now it has become something new. It has become a parallelogram. Parallelogram. two parallels. Okay? Two pairs of parallel sides. And make sure that doesn't run into our isosceles triangle, or isosceles trapezoid, excuse me. Okay, so two pairs of parallel sides. The parallelogram is a type of trapezoid and a quadrilateral. It gets to be everything. Okay. I used to split the trapezoid and the parallelogram up a little bit more, but if we're counting it this way, parallelogram has at least one pair of parallel lines. It could conceivably be a trapezoid. This is much more specific, though. Now, let's say we go from the parallelogram down this way, but we also go from the isosceles trapezoid down this way, and we create something else. Something that has one pair of parallel sides, a second pair of parallel sides that are now identical. They're congruent in length. How interesting. So now we've combined the identical sides, congruent legs, with the multiple parallels, two pairs of parallels, and in doing so, we have ended up with four right angles. So now we have created our friend, the rectangle. Okay. Four right angles. Four right angles. The rectangle is a parallelogram, an isosceles trapezoid, a trapezoid, and a quadrilateral. It is not, however, a kite. Poor kite, still hanging out over here by itself, not connected to anything else. Because again, the rectangle does not have consecutive congruent sides. It has opposite congruent, but not consecutive, not next to each other. But don't worry, our poor friend the kite is not entirely out of business here. Because the kite, remember, one pair of congruent sides, two pairs of congruent sides, but what if the pairs are congruent to each other? If we have something that looks like this, so now those sides are all the same. But the kooky thing is, we also still have two parallels, don't we? So it's a parallelogram, and it's a kite. It is a rhombus. Kind of a flattened diamond. Now, as I'm sure you've noticed, we have one mighty quadrilateral left. And this quadrilateral gets to be everything. It has four right angles. And I forgot to write for our rhombus that it has four congruent sides, which means two pairs of congruent sides, also two pairs of parallel sides. It has congruent legs. We already covered parallel sides. It's got four sides total. Our mighty shape with all of these things, and I'm going to make it big because again it is special and unique, and I'm not measuring it, so if it's not perfect we're just going to have to make do. This shape that gets to have everything that you could argue is the perfect quadrilateral is our buddy the square. The square is a rhombus. The square is a rectangle. It is a parallelogram, a trapezoid, a kite, a quadrilateral. It is everything. It is everything. So be careful on tests and things. If you see a square and it asks for you to label all of the possible names, you basically got to label everything. Now that being said, if a test asks you to identify the most specific name, the most specific term, you want to pick square. Or for one of these other shapes, you want to pick the one that's kind of further down. As we go down, we're getting more and more specific. Higher up is more general. It includes more things. Saying you've got a quadrilateral means it could be any one of these. But if I say I have an isosceles trapezoid, that means it's got to look like this. It has to have congruent legs and a pair of parallel sides. Isosceles triangle is more specific. Now I can get even more specific if I have a rectangle, and most specific if I have a square. You're going to want to use this. The further down you go, the more specific you are. Find where your polygon fits. Find where all of the attributes lead you. If you're traveling down and you ask, does it have one pair of parallel lines, and the answer is no, then you can't go this way anymore. You got to try down here. 2 pairs of congruent sides could be a kite. Now a rhombus is going to have those multiple pairs of parallels, so you can't go any further. This is probably your answer. But you can see you've got a few paths. Alright, because of the diagram, I know this one ran really long, so I will go ahead and stop here. If you have any questions or comments, write them on a sticky note, bring them to class, or you can contact me. But for now, we're going to go ahead and end. I will see you next time. Thank you, ladies and gentlemen.